Right, I'm quickly going to go back to the PowerPoint that I did and just show you there. Remember, right at the end here we did it, and we said, yeah, I showed you that the minute we increase the voltage, we lose less power. Why? Because we are actually then decreasing the current. Okay, right. So can you see what happens is we step up the voltage, and when we step up the voltage, we actually lower the current. Okay, and then less energy is lost during transmission. Right. There is the actual exact answer. We are reducing the current ensures less voltage or power is lost during transmission. Put a big NB there, Matrix, please. A big NB. I'm telling you now, they're going to ask that. Right, and if they ask that and you don't know the answer, it's going to be your fault and not mine. Right, let's go. Calculate the average power dissipated by this generator if the RMS produced is that. Right. Now, the first thing we need to do before we can go to the RMS and that is we must look at our formulas. Right? Here are our formulas. VRMS is equal to Vmax divided by the square root of 2. IRMS is equal to Imax divided by the square root of 2. And then there are my formulas that I'm going to use. So, right, let's quickly see what have they given us in this case. In this case, what did they give us? They gave us Vmax. Let's quickly write it down. They gave us Vmax. Vmax is equal to 325 volts. Then they also told us that IRMS was equal to 13 amperes. And they wanted to know the power. Okay. Now, ladies and gentlemen, they wanted to know the average power. First of all, please don't get a fright when you see a word like dissipated. Just look for the signs. Okay? In other words, dissipated means given off. Okay? But I know you get a fright when you see big words. Right. Now, let's quickly have a look at this. What do they want? They want us to work out the power. Right. Now, what I would have gone and done is I would have used this formula. P average is equal to VRMS times by IRMS. Okay? Right. But now I have a little bit of a problem. Can you see that I don't have VRMS? But VRMS is equal to Vmax over the square root of 2. Okay, so I can use that formula. Please, Matrix, you must use the subscripts. What are subscripts? They are these little things that we are writing at the bottom here. Those things. Please, they are going to penalize you if you do not write it there. Please, please, please. Right, now let's quickly go and see. Let's quickly find the calculator. So, Vmax is equal to 325 volts over the square root of 2. So, 325 divided by the square root of 2 is equal to 229.81 volts. Right. So now what do I do now? Now I go and I say P average, because that's what they want to know from me, is going to be equal to VRMS, which is 229.81 times by 13, which is IRMS. Right, so let's see if we are correct. Times by 13 equals P average is equal to 2987 watts. 2987, let's rewrite it, 2987,53 watts. And remember, power is in watts. Right, if you got that. Okay, do I need to go over that again? Let me just quickly go over it for you. Right, what happened was I was asked P average, okay? I have a formula which says VRMS is equal to IRMS, okay? I've got IRMS, I've been given IRMS. I have not been given VRMS, but I have a formula which says VRMS is equal to Vmax divided by the square root of 2. Vmax from my graph, and that's quite important. I didn't mention that. Maybe I should just mention that again, because some of you might have wondered where I got that amount. I got it from my graph. 325 divided by the square root of 2, which gives me 229,81. I then substituted that back into VRMS, and I solved. Right, okay, got that.